Welcome to the Cyber City Circus Presents Datasheet Digest. My name is David and I will be your host today. Today's episode will cover the datasheet for the Diodes Incorporated PAM8301 filterless Class D mono audio amplifier. This datasheet is freely available from the Diodes Incorporated website if you would like to follow along. If you would like to support the show, you can leave us a written review on Spotify. We appreciate it very much. Thank you. First, we'll start with a summary of the part and of the datasheet. Then we will critique the datasheet with our proprietary 555-point analysis system. The lineage of this part can be traced back to a company called Power Analog Microelectronics Incorporated, PAM or PAM for short. Power Analog Microelectronics was founded in 2004 with offices in Silicon Valley, Shenzhen, Taipei, Tokyo, and Shanghai. The website for the company, poweranalog.com, is no longer functioning. The last copy of the datasheet I can find with the PAM brand on it is marked revision 1.2 and is dated September 2008. The revision 1.3, which we are using in this episode, is branded Diodes Incorporated, and while much of the drawings and the text are similar, this datasheet is not an identical copy of the old datasheet with new branding on it. Somebody put some work into this datasheet. The company Power Analog Microelectronics was acquired by Diodes Incorporated in September 2012 for $16 million. This datasheet we are using in the show notes is dated July 2013, which is less than a year after the acquisition. The PAM8301 is the first in the 8300 series of audio amplifiers. It's now considered NRND, meaning not recommended for new design, even though right now there are 15,000 of them available on the DigiKey website. It appears that it's been superseded by the PAM8302 and the PAM8304, even though they're not directly pin compatible. And it would require a redesign. The PAM8301 comes in a TSOT26 package, which has 6 pins. 2 of those pins are for your speaker connection, 1 pin's for your audio input, 1 pin is an active low shutdown pin, and then there's a power pin and a ground pin. One of the big benefits of using it is that it requires a very low component count to implement. At minimum, you need a capacitor for your signal in, a decoupling cap on your power input, and maybe a pull-up on your shutdown pin. In the datasheet on page 8, under application information, it talks about how to reduce EMI, and it does suggest using ferrite beads and some filter caps there, but only if you're using external speakers. Here are some interesting things about the PAM8301. It's a Class D amplifier. If you don't know a lot about the different classes of amplifier, there's Class A, Class AB, Class B, and Class D. Class D is the most efficient. The PAM8301 can deliver an output power of up to 1.5 watts into an 8 ohm speaker at a 5 volt supply voltage, making it suitable for both small to medium sized speakers in portable devices. The total harmonic distortion plus noise, THD plus N, of the PAM8301 is less than 10% at maximum power output, providing a relatively clean audio output. The PAM8301 operates within a supply voltage range of 2.5 volts to 5.5 volts, making it suitable for various applications and battery types. It has a built-in shutdown control, and it's an active low pin that allows users to disable amplifier and reduce power consumption when it's not in use. This pin is triggered when it is below 0.4 volts and draws less than 1 microamp in shutdown. It has a typical quiescent current of 4 milliamps, which is relatively low for a Class D amplifier, contributing to its energy efficiency. It has built-in thermal and short circuit protection, safeguarding the IC and connected components from damage due to overheating and short circuits. This is triggered at 135 Celsius. The PAM8301 can be operated without an output filter, simplifying the overall circuit design and reducing the number of external components required. It has a built-in undervoltage lockout that goes into shutdown when it's below 2.1 volts. The shutdown has to be toggled back off and back on again after charge, and then shut down again. It uses less than 1 microamp. The datasheet suggests that you can eliminate the power on pop sound if you start the IC in shutdown mode and then switch to an on state following the initial power up. This could be accomplished by using a transistor and a capacitor or a microcontroller pin. This makes sense. The amplifier isn't on when the device is powered on, so you won't get that big pop that comes out of a speaker when you turn something on. Here's a little note about EMI. The data sheet says that you should use a ferrite bead filter to reduce EMI when the speakers are more than 20 centimeters away. It says when selecting a ferrite bead, choose one with high impedance at high frequencies and low impedance at low frequencies. Basically, if you use a speaker that needs a wire hookup, use a ferrite filter on the speaker lines. Now it's time to start our comprehensive 555-point analysis to assess various aspects of this datasheet. The first section is presentation and accessibility. In this section, we assess the language readability, availability, account creation requirements, mobile compatibility, hyperlink searchability, and consistent formatting of the datasheet. Ensuring that the datasheet is user-friendly and easy to access is crucial for efficient use. Some important notes from this section is that it's only 10 pages long, and it really uses every bit of space it has on the paper. For mobile use, it's a PDF and it's clean. It's a good PDF, but it's not optimized for mobile use. In terms of hyperlinks, there's no hyperlinks present, so it didn't get any points for that. This data sheet received 63 out of 75 points for presentation and accessibility. Section 2 covers organization and layout. Here we examine the table of contents and navigation, clarity of information, use of graphics, datasheet structure, consistent terminology, and section and subsection headings. A well-organized datasheet makes it easier for users to locate the information they need quickly. This datasheet does well on that. It doesn't have any subsection headers. Everything's a section, but it's a short datasheet, and that's okay. It uses a lot of standard drawings, nothing special, but it's there. And for its effort, this datasheet receives 42 out of 60 points for organization and layout. The next section is electrical characteristics. This section focuses on the absolute maximum ratings, recommended operating conditions, electrical and dynamic characteristics, thermal and noise characteristics, and output drive capability of the component. These specifications are essential for understanding the component's performance and capabilities. Some notes from the third section is that there are no dynamic characteristics, so it didn't get points for that, but that's okay. It doesn't necessarily need it. It is kind of lacking on the noise characteristics. I would have liked to see them built out a little bit more, but what they have is sufficient. The absolute maximum ratings includes things like your maximum junction temperature and the reflow temperature and storage temperature, but that's all the thermal characteristics. It doesn't really show much else other than that, which is fine. We don't need much more than that to design with this part, but it could have been built out a little bit more. For its effort, this datasheet receives 65 points out of 90 in electrical characteristics. The fourth category is functional description. Here we look at pin configuration, pin functions, function tables, block diagrams, timing diagrams, signal descriptions, input-output waveforms, and functional diagrams. This information is necessary for designers to understand how the component operates and integrates into their system. So I found this section a little lacking, and it really brought to my mind a question of what it is I'm doing here because I'm grading it based on things that's not there, like it's lacking in signal descriptions. It got 4 points out of 10 there because it doesn't really have a lot of description of the signals, but it doesn't need it. And so I give it a lot of points early on for being very efficient with the content and the page count, but then I deduct points later because there's stuff missing. And for that effort, it got 57 out of 75 points. The fifth section is application information. In this section, we assess typical applications, circuit descriptions, PCB footprints and layout, reference designs, application notes, component selection guidelines, and power supply recommendations. This information helps users understand how to utilize the component in various applications effectively. Something noteworthy I realized while grading this section, it doesn't have a PCB footprint layout. It's not included. It has the standard TSOT 26 package dimensions, but it doesn't have the footprint that would normally go with it. So I started looking and I was like, well, why would Diodes Incorporated not provide the PCB footprint? And so then I Googled TSOT 26 footprint, and the very first result was a Diodes Incorporated data sheet specifically on that footprint, how it's packaged, how the PCB layout works, dimensions of the package, how the part is on a reel, and all those things. So I gave it no points for PCB footprint and layout, but there is additional documentation if you look for it, but it's not made obvious from the product website. It's not made obvious from the product's data sheet. You had to go an extra step to find this. Even though the top search result for TSOT 26 footprint was the Diodes Incorporated datasheet for that package, I kind of feel like there was a missed opportunity to tie them together, kind of like how Texas Instruments has their document library. And for its effort, it got 38 out of 60 points. The next section we grade on is quality and reliability. Here we evaluate quality standards, certifications, reliability information, failure rate data, tests and evaluation procedures, environmental consideration, ESD handling precautions, MTBF data, burn-in and screening procedures, and life cycle status. These factors are critical in determining the long-term performance and reliability of the component. This data sheet has very, very little of that. It has an example of a test procedure with a test fixture on page 6, but that's it. It doesn't have any of this reliability information, and for its effort, it gets 8 out of 75 points. Section number 7 is packaging and handling. This section covers packaging information, handling precautions, storage life and shelf life, and labeling and marking. Proper packaging and handling practices are used to ensure the component's integrity and functionality during the shipping and storage processes. This data sheet has none of that 0.0, but a lot of it is in the TSOT 26 data sheet that Diodes Incorporated also wrote. So if it was somehow associated with this data sheet, like there was a hyperlink to that data, or on the product page, there was a link to that and it was somehow associated, I might have given it half points, but I couldn't find any evidence that that's the case. So this data sheet for section 7 receives 0 out of 30 points. Next is support and documentation. Here we analyze additional documentation, design resources, technical support, community resources, errata sheets, FAQs, software tools, drivers, and application examples. Comprehensive support and documentation is essential for users seeking assistance and guidance when working with this component. Again, I looked, I gave more than a cursory glance into this, and I found nothing other than that TSOT 26 data sheet, which I had to go look for. So I gave it a few points for that. The places where you'll get this most support for this component and this data sheet is places like Adafruit.com and DigiKey.com's tech support forums. Unfortunately, Diodes Incorporated has very little in terms of support outside of actually calling an FAE, which I've never had to work with a Diodes Incorporated FAE before, but my experience generally with FAEs isn't great. And for that effort, it gets 4 out of 60 points. The next section is updates and revision control. In this section, we review the revision history and update frequency of the datasheet. Regular updates and a clear revision history help users stay informed about changes and improvements to the component and the documentation. This document has 0 revision control and update history, and that's fine. So it got 0 out of 30 points. The next section is the overall impression. Finally, we assess the organization and clarity, completeness of the information, and relevance to the application. A positive overall impression is essential for a useful and reliable data sheet. And generally, I don't see anything necessarily wrong with this data sheet. I like this data sheet. This is a good data sheet upon initial glance. And so I gave it a full 15 out of 15 points. And now we're completed the grading process, and the total score is 299 out of 555. Wow. Going into this review, I really thought that this sheet would grade very high, and I am surprised by the outcome. Overall, this is a great data sheet if you're starting out and you're looking for a beginner data sheet. I highly recommend it, even though it did kind of grade low. The places where I think that this data sheet could improve is that if it had more completed information. It has a lot of the fundamental information. It has everything you need to really get started, but you have to dig deeper to actually implement it. And while that's okay, the score reflects that. Well, that's it for this week's episode of Datasheet Digest. Tune in next time when we covered the Maxim Integrated DS1307 I2C real-time clock. I've already started looking into it, and it's going to be a wild one, so don't miss it. All music provided by Vexagon in Augusta, Georgia. Be sure to follow us on Twitter at Datasheet Digest, and check us out on the World Wide Web at www.datasheetdigest.com. I'll see you next time.